Definition you need to know. One more time. An operational amplifier is a high gain
linear
primary purpose is to provide
high input impedance.
we have high input low output impedance.
and high gain linear amp direct couple, high Z and low Z out. What about the current voltage power gain? So we can say high also, or very high. I hope we remember at least one thing since PDO 1 is power is a product of current and voltage. That's it. Amazing. Okay. Basic definition. That's what you got to know right there. Boom. And there are many different configurations you can place this thing in. Primarily, you can have what's called an open loop or a closed loop. Open loop means what?
No feedback.
No feedback. Means no feedback. So therefore, the chip that we talked about, the LM741, and its main purpose is voltage amplification, that's what it's for. If I leave it in an open loop configuration, the gain for this type could exceed what?
200,000.
Very good. It'd be greater than 200,000. And we did an example, just so you can understand how it works and what it's supposed to do. But the only thing that you are required for purposes of this course is characteristics. What else do we need to know about this thing? Open loop, got it. I can use this configuration like comparator or comparing a reference to an input. Yeah, that might be something you want to remember. Comparator, open loop. You can use this thing as level detector or level detection. It's kind of the same thing as this. Comparator is kind of synonymous. But we'll throw that up there too. What else? How about wave shaping? We do that too, right? Wave shaping, setting a specific threshold, and we end up with basically a square or rectangle wave. You want to know these things. Purposes, you can call them. Purposes, comparator, level detection, wave shaping. Probably want to know that. How many inputs do we have to an op amp? Two. The one that has a little negative sign on it, what do we call that thing? Inverting. What? Oh, output, really? Input. Inverting input. Input. Well, the positive symbol on it is the non-inverting input. So if I have in my input here, notice it's a variable resistor, and then I have a reference, a fixed reference. And it doesn't matter what the reference is for purposes of understanding characteristics. If I change this, the op amp is going to detect that level, and it's going to change the output. But in an open loop configuration, how do we know what the output's going to be, or where it's going to go? Open loop, how do we know? Let me use a different thing. Shut up. Remember this? The rail voltages, positive, negative VCC. Open loop it, that's where it's going to go, isn't it? The output's going to swing either way. Based on the difference, whichever one's the boss, that's the direction it's going to go. Open loop. So that's where this comes in here. But when we tie in some type of feedback, I can control the level of output. Open loop, closed loop, big difference there. You also have to know what the three main functional areas are of the op amp. Right here, inverting input, non-inverting input. This first portion or block, what do we call it? It's called the differential amplifier. Basically, here's the part where it takes the difference. And then we looked inside of the chip during the lesson. And then we saw Q1 and Q2. And the inputs were on, the two inputs were on the bases of those transistors. So that's where we get our high input impedance. Just think about BEO group. Whenever the input's on the base, the impedance is always going to be high. It always is. Take the difference. What's going on in the middle, roughly? What do we call it? Voltage amplifier. Near our output, what makes sense to call it? Output amplifier. Holy crap. So with a high input impedance, I can get away with a very small input because it's going to be amplified anyway. That's the point. And all this stuff is on an integrated circuit. Output. Why is the impedance low? Everybody remember? Yeah, it's a common collector configuration. Remember we looked at the internal workings of the chip, Q8 to Q9. That's where our rail comes from, positive, negative, BCC, common collector. The two emitters are tied together at the output. Whenever we're dealing with input, outputs on the emitters for impedance goes, it's always going to be low. Just think about that already forward bias junction emitter basic. Should make sense. Closed loop. What's going on with the closed loop configuration? We have feedback. Now we can control the level of output by feeding a portion of it back into the input. And we did an example with this too. We had like 1 volt peak to peak, 10K ohm resistor, 1K here, figured out the current, and determined what the output voltage is going to be because it's set at a specific level. And I can change the level output by removing this feedback resistor and making it smaller or whatever. Again, purposes of this below is characteristics. I only showed you examples so you have a better understanding. Characteristics where it's at now. Feedback resistor, closed loop, got it. The feedback, where is it going? Yeah, it's coming back to the inverting input. Well, got it. You already know it's called that, but there's another name, or what kind of feedback do we call that?
Degenerative.
If it's on the inverting input, it's called degenerative feedback. It's degenerative. What else can we call it?
Negative feedback.
Yes. We can also call it negative feedback. You know that. It's brought back to the inverted input, degenerative feedback. I'm going to talk about that down here. I'll mention that down here when we get to this part. So, as far as basic characteristics, that's all you got to know. What about this guy right now? Still using feedback, but now it's brought back to the non-inverting input, and we call that what? We call it regenerative. And yeah, we can say positive feedback, it's using the hysteresis, that lagging effect that's left over, yes, all the same stuff. And I'm going to write that, hysteresis, because it's referring to the same type. Positive feedback, regenerative. This sub H should clue you in. Probably stands for hysteresis. This F just feedback. But they are different. A balanced op amp, what is, or what must be true about that? The differential voltage has to be 0. 0. And that has to do with this virtual ground, that point right here, and even here, right here, virtual ground. Virtual ground. And the fact that they're both what? What do we call, if an input is tied to ground, what do we call it? Zero based, yes. Zero based, not biased, based. Here and here. Zero based, virtual ground, Differential input, 0. That's what it's based off of, balanced. That's all this stuff.